We're going to do a separate short video here on the p-value, piggybacking on the example of the one sample t-test. The p-value is maybe the most important and the most confused topic in an introduction to statistics course. You have to memorize the definition of what a p-value is, and maybe more importantly, what a p-value isn't. So we'll recap this here. The p-value is the probability of observing. What this means is you're going to take some data. You're going to take a sample. You're going to calculate a number that summarizes that sample, and you're going to say, what's the chance that I would get that? The probability of observing a test statistic. When we first talked about this, we hadn't done the idea of test statistics, but now we have. We've done T, right? T is a test statistic. It's a number that summarizes your data. The probability of observing a test statistic of a given magnitude, it's like, what's the chance of getting my data? In lay terms, this is like, what's the chance I would see what I got? The probability of observing a test statistic of a given magnitude or larger, and this part is really important, if the null hypothesis is true. Is true, were true, is true, were true. If the null hypothesis were true. So we know that it's a probability. It's going to be something between 0 and 1. We know that we have to state some sort of null hypothesis. And we have to sort of draw out, hey, this is what I would expect to see if the null hypothesis were true. I would maybe expect to see something like this. But what did I actually see? Well, I actually saw something like way over here. Well, that's weird. How weird is it? That's pretty weird. Maybe the null hypothesis isn't actually true. And that's how statistical tests work. The probability of observing a test statistic of a given magnitude or larger if the null hypothesis were true. Pause your video right now and write that down 10 times because you need to memorize that. This is how it works in the t-test. We saw when we took these Frisbees and we filled them up and we said how much beer fits in the Frisbees, blah, blah, blah. Our t-statistic, the one number summary, was 10.49. And remember what the t-statistic is. What is my mean relative to the hypothesized population mean? That's the Greek letter mu with a little 0 underneath it. And then we divide it by the SEM. There it is. It's 10.49. It's really big. So if the null is true, now we need to think about it. If the null is true, either we are very, very, very unlucky, or lucky, depending how you look at it, or maybe the null isn't true. Maybe these data will convince us that the null isn't true. And what we've talked about and what we're going to state more explicitly soon is we're going to draw some criterion for weirdness or some cutoff that says, hey, if I see anything that's way up there, I'm going to reject the null hypothesis. And you'll sometimes see this written out. This area over here might be known as the rejection region. Most people put 5% of the curve in the rejection region, 2.5 on this side, 2.5 on this side. And if your data end up in that spot, we say we reject the null hypothesis. So this is what the p-value looks like visually. If you want to put it into words, how to assess statistical significance, it's this. The p-value is the probability of observing a test statistic of a given magnitude or larger if the null hypothesis is true. That's all it is. Memorize that, understand it, be able to explain it in English. This will be on the final exam, guaranteed.